Greetings everyone. Today we'll be seeing on the topic zinc polycarboxylate. Craig gave a classification of the cements that is based on water, oil and resin. Under water-based cement we have the GIC, resin modified GIC, zinc phosphate and zinc polycarboxylate. Under oil-based we have zinc oxide eugenol and non-eugenol cement. Then comes your resin-based cement. So this is a classification which is given by Craig based on three, that is water-based, oil-based and resin-based. So zinc polycarboxylate has an ADA specification number of 96. Please remember ADA specification number of 96. Who introduced it? It was introduced by Dennis and Smith in 1968. So what is the keystone of this polycarboxylate cement is that it was the first cement which had the potential of adhesion to the tooth structure and it was not mechanically bound to the tooth structure. It was chemically adhered to the tooth structure. So what are the various applications? It was primarily used for luting of permanent restoration, for liners and bases, and then for orthodontic brackets and for cementation of bands. What is the old ADA specification? Any guesses? So the old ADA specification number is 61 and the present one is 96. So coming to the composition of your zinc polycarboxylate, let's take the powder first. So in the powder we have 90% of zinc oxide, 10% of magnesium oxide and traces of fluoride. So 90, 10 and traces of fluoride. So when we have all these products, these are all separate products, right? So how do we mix all these products? So initially we need to heat all these material at a higher and the greatest temperature. So when you heat it, these material melts together and binds together to form as one single solid rock. Okay, so now you cannot use this rock directly to apply on the tooth surface, right? So this rock is then broken down into powder form, which is known as pulverization. So coalescing of all these material and making it into a single component is sintering, and then breaking that component into powder form is known as pulverization. So this is how your powder is ready for the zinc polycarboxylate. So why do we need fluoride when almost 100% of components are ready? So this fluoride helps in increasing the strength and it regulates the setting time and also improves the viscosity. Coming to the liquid component, the liquid has 32 to 42% of polyacrylic acid, zinc polycarboxylate. So it has polyacrylic acid, right? So what is the molecular weight of this polyacrylic acid? The molecular weight ranges from 30,000 to 50,000 Daltons. So this molecular weight helps in chemically adhering to the tooth structure. Clear? Apart from polyacrylic acid, it also has itaconic and malic acid, and the pH is adjusted using sodium hydroxide, and it also has tartaric acid. So the four major components includes polyacrylic acid, itaconic acid, malic acid and tartaric acid, and the pH of this is adjusted using sodium hydroxide. Okay, so the tartaric acid is that one particular acid which helps in prevention of gelation. What is gelation? When the liquid melts or it becomes in a gel-like consistency. Okay, so what are the water settable cements? So in water settable cements, the polyacrylic acid is freeze dried. Okay, and then the powder is mixed with the cement powder. The polyacrylic acid is mixed with your cement powder, and the water which is present in the liquid helps in the processing of your cement. So the clinical application includes luting cements for base alloys. It acts as a thermal insulating base under metallic restoration. It helps in cementation of orthodontic brands. It also helps in cementation of pediatric stainless steel crowns. So what are the properties of your zinc polycarboxylate? First and foremost, it is biocompatible. Okay, when you initially mix the cement, it has a pH of 1 to 1.7, which is kind of acidic. However, after it is mixed, it goes to a pH of 3 to 4, okay, which is mild response to it gives a mild response, pulpal response. Okay, it is acidic in nature initially, but it is mild when compared to the other cements. And over a period of 24 hours, the pH of the cement goes up to 5 to 6. So why is it biocompatible? Because it has a weaker acid. Second, it rapidly rises to neutrality. It has a molecular size of higher molecular size of acid molecule, which is 30 to 50,000 Dalton. It is chemically binding to the tooth structure, and it also has fluoride release. So what is the viscosity of the cement? How does the cement feel? It is kind of little thicker when compared to the other cements. What is pseudoplastic here? Pseudoplastic is nothing but under pressure, okay, when the cement is having a stress, under stress, it is able to flow equally on the floor. So that is the pseudoplastic nature. Next, coming to the strength of your compressive strength. The compressive strength of your zinc polycarboxylate is 80 megapascal. So the tensile strength is 8 to 12 megapascal, and the elastic modulus ranges from 4 to 6 megapascals. The solubility is 0.12% to 0.15% by weight. So how does it adhere to the tooth structure? It has a chemical bond with the tooth structure. How? The carboxylic group of the polymer chelates with the calcium in the tooth structure. So once it chelates the calcium tooth structure, there is an interlocking which happens. So that is how it is chemically bonded to the tooth structure. And the bond strength of the enamel ranges from 3.4 to 13 megapascals, and to that of dentine it ranges from 2.1 megapascals. Under the ideal conditions of manipulation, the adhesion of polycarboxylate cement to clean dry surface of enamel is much greater than that of the other cements. If the cavity is not dry or not clean, the cement cannot bond with the metal as well. To improve the mechanical bond, the surface should be carefully abraded with an abrasive material or stones. Okay. The presence of saliva also reduces the bond strength. Just in case, if the cavity is filled with saliva or pooled with saliva, please make sure you completely dry the cavity and then apply your zinc polycarboxylate as a base so that there is a better bonding. Second, it gives better thermal stimulation. Okay. Unlike zinc phosphate, zinc polycarboxylate adhesion is better in smooth as well as rough surfaces. It does not adhere to gold or porcelain, but the adhesion to the stainless steel is excellent here. Now let's look into manipulation of your zinc polycarboxylate cement. Coming to the manipulation, what we do here is we take powder and the liquid. We take a glass slab and a spatula. We have to take 1 scoop of powder and 2 drops of liquid. First, the powder has to be dispensed and then the liquid has to be dispensed. Okay, the liquid has to be tilted to 90 degree and then given one proper squeeze. So it is mixed in the ratio of 1:1. Okay, so what we do here is then split the cement into 3 equal parts. Okay, once we split the cement into 3 equal parts, we mix the cement, we slowly incorporate the cement into liquid and start mixing in the circular motion. So this is how you manipulate your zinc polycarboxylate cement, unlike zinc phosphate, which is done in 6 increments and larger circles for dissipation. So before dispensing the powder and the liquid, we have to know that we have to shake the bottle well. Even for the powder, we have to shake it nicely and then tap it on the top so that the powder settles down, and then scoop out the powder. Also in the liquid, we have to shake the liquid and then dispense it at 90-degree angle so that it has one single drop and there is no air entrapment. So what is cobweb here? If you see, when the gel becomes hardened, it has a cobweb-like appearance. So this is most commonly seen in polyacrylic acid. So how to increase the working time? The working time can be increased by addition of water, increasing the temperature of mixing environment and cool glass slab technique, and also by refrigeration of the powder. Can you freeze the liquid? There is going to be gelation of polymeric liquid due to hydrogen bonding if you try to freeze the liquid. So you should never freeze the liquid. How to remove the excess liquid? After restoration, the margins can be coated with petroleum jelly to avoid dehydration, and after the cement is set hard, it becomes rubbery stage. Coming to chelation reaction. The initial mixing time is 30 to 40 seconds and the final setting time is 7 to 9 minutes. The advantage of using polycarboxylate is that it has chemical bonding. I repeat, it has chemical bonding unlike the other materials. Second, it has mild pulpal responses. And third, it is anti-karyogenic. The disadvantage includes during setting, it becomes a little rubbery in consistency. It has shorter working time, however, longer setting time. It is opaque when compared to the other material and the compressive strength is poor. So to conclude, each evaluation should be appraised and based on the environment, you have to decide which material favors which environment. This is my reference for the current presentation. Thank you. Have a nice day.